Hello friends, let's start our topic multivariable calculus. Now, in general, what we understand when we talk about calculus? Calculus is nothing but the study of curves. So, when we are talking about any curve that is in the xy plane or in the yz or in the xz, we simply talk about the vicinity, we simply talk about the tangents, we simply talk about the normals and if that curve is cutting any line or intersecting any line or parabola or hyperbola anyways. So this is what calculus helps us in to understand the family of curves, to understand the nature of curves. Now we must know that when we are talking about any y is equals to function, a singular function like y is equals to fx, we see that it is a single planar curve, that is it comes under a plane, xy plane, or if it is like z is equals to fy, then it will come in the yz plane, similarly as for the xz plane. Now suppose, what is the multivariable? Multivariable means that here we are talking about more than a plane, we are talking about a function which is dependent on more than one variable. Here in a single variable I have function which is dependent only on x. Now in multivariable I will have function dependent on more than one, that is, let's say z or omega is equals to f x comma y. So this is what multivariable is all about. Now here we cannot say that it will come under a plane, that it will come under a single plane, that is xy plane or yz plane, just like similar I have drawn here an xy plane. No, it will not. Rather it will come as a entire surface in a three-dimensional plane, that is as a real object, as we see a cylinder, a sphere, anything, a cube, any real world object. This is what multivariable is all about. So one thing we need to notice is that when we have fx, that is one variable, we get a 2D figure. When we have fx comma phi, that is two variables, we are getting a 3D figure. So in reality, just asking you a question, in reality, do we find anything other than three-dimensional? Well, you will say no, but in mathematics we can find as many as dimensions, we can assume as many as dimensions. Let's say these x, y, z and so on, many alphabets gives n variables, so it will give n plus 1 dimensions, that is n1d figure, dimensional figure. This is the basics of multivariable calculus. Now what we are about to start is actually the limits. The limits in multivariable is different than the limits in a curve or a single variable calculus. How? In a single variable calculus, let's say I have a curve, and using a limit, what we basically do is that we find whether whether the point at which the limit is tending to is becoming what value of the fx, I mean the function, the codomain or the range. This is the function of limits in a single variable. We take a point, we extend x to that point, and we simply check what is the function by putting x. Or more, if we talk about more limits in single variable, then we find continuity, the concepts of continuity. We have to check a point, let's say a, then we have to take some point like a plus h, so as h is very less than 1, then we again take, let's say, a minus h, where same value h is very less than 1. So h will create very little difference in the values of in the values as compared to a, because a plus h, a minus h and a will tend to be equal since h is very less. But still, why are we taking a plus h and a minus h? Just to see that whether at those points the same function we are getting, the same value of y we are getting. Now, so the theorem we already know is that x tends to a plus h, fx must be equals to limit x tends to a plus y of f a plus h, I'm sorry, it will be a minus h of fx. So at this point we can understand that the test has been concluded. Now the last thing we need to do for the single variable is that limit x tends to a fx. If these three are equal, then we can say that it is continuous. But in multivariable this doesn't happens, because in single variable calculus we simply use a singular plane and we use a curve. In a curve, x-axis acts as like an number line where it starts from 0, 1, 2, 3, and again it goes back to -1, -2, and so on. It acts like a number line, and that is the reason why a curve can be treated into two ways, like LHL, like left hand limit and right hand limit must be equal in case of a two-dimensional figure. Now when we are talking about real space and time, there is nothing called sides or nothing called hands. We never say left side of the sphere or the right side of the sphere. We say in terms of halves, in volumes, the first half of the sphere, the second half of the sphere. So there is no concept of left hand limit equals right hand limit in a multivariable limit equation. So as a result, what is the main thing? Suppose in a real space-time axis, there exists a point P, x comma y comma z. So when we are talking about the limits or the continuity of that surface along that real-time axis, all we need to do is that we have to consider all the points, be it on the xy plane, be it on the yz plane, be it on the zx plane, nearest to that point. So while solving the problems of limits, we cannot take all the points in the vicinity of that point P. Why? Because in the vicinity of P there are infinite number of points and we cannot do infinite number of equations to solve a single problem. So the best thing we can, so this is the conclusion, that multivariable limit is different from the single variable limit in a huge aspect. In single variable limit we are only using two sides. There are only two sides, left side and right side. In the multivariable limits there is no concept of sides, first of all, and secondly, while we are talking about vicinity, there are infinite points on the vicinity. We cannot take infinite equations, as I have told earlier. So we must not forget that these multivariable limits must be solved in a different manner as compared to the single variable limit. And even if we are taking any point vicinity with the point P, then we must not forget that the sum is actually incomplete, the proof is not actually done, because just by solving 2 or 3 points and finding and also finding the point P, the limit at point P, when we see that all the 3 points are equal, we cannot say that all the remaining infinite points will be equal. So solving the limits in multivariable is totally different than solving the limit in a single variable, and this is a very big mistake which is most of the time done while solving the problems. Thank you.